Hello everyone, welcome to IB Army and this is Jenny. So today we're going to continue on our study of differentiation, and this lesson is specifically about tangents and normals that use the differentiation techniques in calculus. So what are actually tangents and normals? Tangents is the curve that just touches the curve at that point. So basically it touches a point on that function and it will form a linear line with that according to that point, and normal is perpendicular to the tangent line. So its tangent is basically that point that is basically the rate of change of that curve, so you can use differentiate technique, and normal will use a formula to convert it from tangent to normal. So without further ado, we're gonna jump into the question again and see how should we do it. So first of all is find the question of the tangent to the graph of y equals to x cubed minus 3x squared plus 1 at the point for which x equals to -1. So I haven't introduced any equation or formula yet, so we're just gonna use this as an example. So first of all, you're always gonna differentiate first. You differentiate the function and get the derivative, which is 3x squared minus 6x. And then you have the point where x equals to -1, as we stated. That's the tangent point. You substitute that into the derivative and you get a number which is 9 in this case, and that's the slope of the function of that tangent curve. So for each function you will have an equation, and especially in tangent it's a linear function, so you'll have a slope which is 9 in this case. And as I stated on the top of this page, the basic formula for tangent curve is basically the same with a linear equation, y minus y equals mx times x minus x. So what we have to find is the capital Y, X, and M, and Y, small y and X, they're just variables. So you find y at this point using the original equation. Be careful, here is not the derivative but the original one. So you find the coordinate of x and y, which are the capital ones. So now you have m, which is 9, x is -1, y is -3. You substitute them back into that first equation and you get that the function for the tangent is y equals 9x plus 6. So use the formula on the top, and remember that you have to find 3 points in order to find the equation. So let's do the second question now. Find the equation of the tangent to the curve y equals 3x squared minus 2x plus 1, which is parallel to the line y equals to 10x. So there's something different here, which is parallel, but with your algebra skill, I think you know what to do. So pause the video and try to figure it out. So again, the first step is always differentiate. In this case, you already know that as the question stated, the tangent of the curve is parallel to the line y equals to 10x. So we know that for the tangent curve, the m will be 10 because they are parallel, and we know that parallel lines have same slope. And then we have to find x and y using the derivative function in this case, because that point is not only for the original function, but it also exists at the tangent curve. That's the only interaction or the similarity between these two functions. So you can find that point and you substitute that into that top equation, and you find that the answer is y equals to 10x minus 11. Third question, find the equation of the normal. Oh, it's different now. to the curve at the point for which x equals to 3. Find the x coordinate of the point where the normal meets the curve again. So we actually have two questions here. Let's just answer the normal one first. If you have an extra idea, please keep doing it and try to finish the second one. So again, it doesn't matter if it's tangent or normal, we still have to differentiate the regional function first. So we have the rate of change, which is of the curve is 2x minus 2. And then you know that at x equals to 3, m equals to 4. And then you have to find the gradient of normal. So we know that if they are perpendicular, the product of the slope of tangent and normal is -1. So you set up 4 times m2. m2 in this case is the slope of the normal curve, and you find that m2 is -1/4. And then you find x and y again, you substitute them back, and that that gets you to 4y equals to -x plus 11. And then the second point where it will meet again. Now you have two equations. So it's you set up a simultaneous equation and then you solve for it. And because x equals to 3, we already know, so we use the other point, which is -5/4. Last question. Find the equation of the tangent to the curve y equals to square root of x at the point x equals to a and a is bigger than 0. Don't be scared by it's not a real number, but a parameter. You're doing the same thing. Pause the video and try to work it out. So again, the first step is always to differentiate the original equation. And in this case, you don't have a real value, but you still can find m by substituting x equals to a. And you find x and y by using the original function, and you just substitute them to the y minus y equals to mx minus x, and you get that. So it's the same thing. Don't be scared. And we have a little conclusion here. So in order to calculate the gradient, the function for gradient and normal, you have to have 2 points or 1 point and the gradient. And you always use the formula y minus y equals mx minus big X. And gradient of the tangent is differentiation point of tangency. Normal is 1 over that gradient of tangent, or -1 over gradient of tangent, something wrong. So the procedure is always differentiate and then find the gradient at that point. So just remember these small details and you'll ace all the tangent normal questions. See you next time.